Okay, so understanding Pythagoras' theorem. So I've got a right angle triangle here, and you can see that I've drawn a square on the left-hand edge of it here. I've drawn a square on the bottom, and I've drawn a square here on the hypotenuse. And I hope you can see that the square C has a bigger area than A and B. And because it's a right angle triangle, in fact, the area of C is the total of the areas of A and of the area of B. So if you know the area of A and you know the area of B, you can work out the area of C. And that's really useful because if, for example, I were to draw a right angle triangle here, if, for example, you knew that this side was 3 and this side is 5, you can work out the length of this side. And this is how you do it. You have a think to yourself, okay, what would the area be of this square? And what would the area be of that square? If you knew both those areas, then you can work out the area of the square which would be on the hypotenuse here. Let's do that quickly. The area of this square, 3 times 3 is 9. The area of this square, 5 times 5 is 15. So to work out the area of the square on the hypotenuse, we know it's the total, 9 and 25. So the area of this square is 34. So that means that x must be the square root of 34, which you can work out on your calculator. All right. Let's do one more. Let's draw it another way up. Let's draw it like this, and like this, and like this. And we will have 6 here and 4 here. We need to find x. Now, x is the hypotenuse. It's opposite the right angle. So I know that the square on the hypotenuse is going to be the biggest one. So the hypotenuse is the longest side. And I know that I can work out this area by just working out the area of the square, which would be here. That would be 4 times 4, so that would have an area of 16. The square here would be 6 times 6, it would have an area of 36. So the area of the square on the hypotenuse must be 16 plus 36, which is 52. So that means that x must be the square root of 52, which you can work out on your calculator. So, in all of those, I had to work out the hypotenuse. And I used the fact that the area of the square on the hypotenuse is this area plus this area. Let's do one where you know the hypotenuse and you have to work out the length of one of the other sides. So, let's have a look at this triangle here. And let's imagine that you know that that's 10. And you know that that's 6. And you're asked to work out this length. Right, now we know the area of the square on this side is 36. 6 times 6. We know the area of the square on the hypotenuse is 10 times 10, 100. Now, we don't know the area of this square, but we do know that 36 plus this has to be 100, because the area of this one is that one plus that one. So 36 plus this is 100. So this one here must be 100 take away 36. So the area of that square must be 64. And now to work out x, I can just do the square root of 64, which is of course 8. It's 8 eighths, 64. Okay, let's have a look at one more of those. So in this one, again, I'll tell you what the hypotenuse is and one of the other two sides. So let's have a hypotenuse of 8, and let's have this side this time being 6, and that's unknown. Right, this is the right angle, so the 8 is the hypotenuse. The 8 is the bigger one, isn't it? 8 eighths is 64, and this one here, 6 eighths is 36. So of course I don't know the area of this square, but I do know that 36 plus that one has to equal that one. So this one is going to be 64, take away 36, which is 28. So the area of that is 28, so x must be the square root of 28, which you can work out on your calculator. All right, so all you have to do is to work out the areas of the squares that you know, and then decide, do you add or subtract before you square root?